The objectives of this experiment are to understand the terms epilepsy and convulsions or seizures, to know classification of seizures and its behavioral manifestations, to know that electroencephalogram, that is EEG, is employed to detect neuronal excitability, to understand that epileptic seizures can be evoked in normal brain by kindling, that is, by electric shock or chemical convulsant, to know that anticonvulsants are employed in the treatment of epilepsy. Epilepsy is a group of CNS disorder characterized by brief episodes of seizures. Seizures are also referred as convulsions. Convulsions are paroxysmal episodes of spontaneous, uncontrolled neuronal discharge and are characterized by tonic body movements and or disturbance in consciousness along with change in motor, sensory or behavioral activity. Epilepsy is classified on the basis of nature and pattern of abnormal activity and abnormal neurotransmission. Generalized epilepsy. It is characterized by widespread involvement of brain, bilateral motor manifestation, and impaired consciousness. Partial epilepsy. In this, abnormal neuronal discharge is limited to certain areas of the brain with or without loss of consciousness. Generalized epilepsy is further classified into grand mal, petit mal, akinetic, myoclonic seizures, and infantile spasm. Partial epilepsy is further classified as simple partial seizures and complex partial seizures. The electric shock induced convulsion in animals represent grand mal epilepsy. Chemical induced convulsions with strychnine represents petit mal epilepsy. Chemical induced convulsions are characterized by tremors, hyperexcitability, clonic phase followed by tonic phase, and deep abdominal respiration is seen. This episode of convulsions results from either decrease in concentration of GABA, glycine, or an increase in concentration of acetylcholine, glutamic acid. Strychnine, a CNS stimulant, inhibits glycine and induces convulsion in animals. Anticonvulsants like diazepam acts as an agonist of GABA and inhibits spread of abnormal transmission in brain.
To study the effects of convulsant and anticonvulsant in mice, select 2 adult healthy mice weighing not less than 20 gram and label them as mice A and mice B. Observe their normal posture and normal muscle tone, particularly in limbs and tail. Now inject 0.1 ml of stock solution of strychnine hydrochloride to mice A intraperitoneally. You can see that strychnine induces clonic convulsions characterized by Stroop's tail, that is, S-type erection of tail and jerky movements of whole body. These clonic convulsions finally leads to death of the mice A. Inject 0.2 ml of diazepam solution intraperitoneally to the mice B. After half an hour, administer 0.1 ml of strychnine sulfate solution intraperitoneally to the mice B and observe the onset and severity of convulsions. You can see that severity of convulsions such as stroke, whole body movement is less in these mice. This suggests that diazepam protected the mice from the convulsions induced by strychnine. Clinically, diazepam is useful in different forms of epileptic seizures and also as a drug of choice in status epilepticus.
You have learned that convulsions induced by chemical agents produce clonic type contractions characterized by jerking of head and body and Stroke's tail. Anticonvulsant activity of a drug under test is complete protection from convulsions.